So let's suppose there is some object which moves along circumference of this circle. So motion of that object is circular motion. Now there are two types of circular motion. First one is uniform circular motion. So if object moves along circumference of circle with constant speed, then its motion is said to be uniform circular motion. If it moves with variable speed, if its speed changes, then it is non-uniform circular motion, right? So then let's suppose this is our object. It starts from this point. It can be anything. What are some examples of circular motion? So simplest example is you take a stone, you tie it with a string and you whirl it like this. Okay, that is an example of circular motion. Then you have studied about atoms, right? So in Bohr's model of an atom, okay, in Bohr's model of an atom, the electrons revolve around what? The nucleus in circular motion, okay, in circular orbits. So that is another example of circular motion. So electrons in atom revolving around the nucleus, okay. So that is semi-classical model of an atom. Then, so another example can be given, motion of earth around sun. Okay, it is elliptical, but we can think of it, okay, approximately as a circular motion. Okay, so these are some examples of circular motion. So let's suppose this is any of those objects. Okay, it starts at this point A, it moves along the circumference of this circle. So in some time, let's call it delta t, it moves from point A to the point B, to this point B, right? So its radius vector will move through some angle. Okay, the radius vector moves through some angle. Let's call it delta theta. This is the initial radius vector. This is final radius vector in this much time. So we can define a quantity here analogous to the displacement. So what would be displacement? Displacement is just shortest distance between start point and end point. So it is a straight line starting from A ending at B. And here this radius vector subtends an angle delta theta at the center in time delta t. So we can define angular displacement. Okay, so angular displacement I am denoting by delta theta, and it is the angle through which radius vector moves when particle moves about around the circumference of circle. Okay, then next we can define an angular velocity. So angular velocity we denote it by omega. Okay, and this is a vector quantity, this is also a vector quantity. So it is delta theta divided by delta t. Okay, so angular velocity is angular displacement divided by time. Okay, so this is a vector quantity. Okay, so now magnitude is clear. Magnitude would be what? Whatever is the angle covered by this radius vector, it is the magnitude of angular displacement, and that angle covered divided by time will give you angular velocity, right? But what about the direction? So why is it a vector quantity? Because see, there can be two kinds of movement of this particle around the circumference of circle. One is the anticlockwise sense and other one is the clockwise sense. Okay, the other one is clockwise sense. And now the clockwise and anti-clockwise, these two directions are different. They are not same, right?
Yes, sir.
Okay,
Yes, sir.
so anti-clockwise and clockwise are two senses of rotation or two senses of revolution of an object in circular motion, okay, for a fixed circle. Okay, and those two senses of revolution are opposite to each other, so we can't say that when an object moves from A to B and the other object or the same object, let's say it moves from B to A, these are same rotations or same revolutions, we can't say that. Okay, so the angular displacement is a vector quantity. Okay, and how do we find the direction of the angular displacement? So it is found using the right hand thumb rule. Okay, it is found using the right hand thumb rule. So what is right hand thumb rule? Take your right hand, curl the fingers of the right hand in direction of motion of particle in circular motion and stretch your thumb. So your straight thumb will give you the direction of angular displacement. Okay, so straight thumb gives the direction of angular displacement. So here my tab is kept like this and my object, this object is moving from A to B in anticlockwise sense. So what would be the direction of angular displacement? So I will take my right hand, curl the fingers of right hand in direction of motion of particle and stretch my thumb. So here it is vertically upwards. So is it the same for all of you? Now this is how we find out the direction of angular displacement. What about angular velocity? Direction of angular velocity will be same as that of angular displacement because only delta theta has direction, time doesn't have direction. Okay, and what is unit? So unit for this is radians and unit for the angular velocity, unit for the angular velocity is radians per second. Okay, after that we can define the angular acceleration. Okay, so if the particle moving in circular motion speeds up or slows down, okay, then there will be some angular acceleration. Okay, so if particle is moving fast, angular velocity will be more. If it is moving slow, then its angular velocity will be less. Okay, so let's suppose that omega 1 is the angular velocity at time t1, angular velocity at time t1, and omega 2 is the angular velocity at time t2. Then just like acceleration is change in velocity divided by time, it is angular acceleration is denoted by alpha. So it is final angular velocity minus initial angular velocity divided by final time, okay, t2 minus the initial time t1. Okay, and you can write this as delta omega bar divided by delta t. And what would be its direction? What would be the direction of angular acceleration? If the object speeds up, okay, if this object speeds up, then omega 2 will be greater than omega 1, right? So omega 2 minus omega 1 will be positive. So then it is in direction of omega. And if it slows down, then omega 1 will be greater than omega 2. Okay. So this difference will be negative, and then in that case it will be in opposite direction of omega. Okay. So if the particle speeds up, omega 2 is greater than omega 1. Then alpha is in same direction as that of omega. Alpha and omega are in same direction. Okay, and if particle slows down, particle slows down, then what will happen? So omega 1 will be greater than omega 2. So the difference would be, this difference would be negative because omega 1 is greater. Okay, so alpha and omega are in opposite direction. Okay, is it clear? Yes, no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so then now let's suppose an object is moving like this in this circle, okay, it is horizontal circle in anti-clockwise sense. So tell me what will be direction of its angular velocity. So for this object as well as this object.
Yes, sir. Upwards and
Yes, sir.
downwards.
Upwards and downwards. That's what I'm asking. Okay. So direction of angular velocity will be upwards in first case, okay, and downwards in the second case. So everybody understood this?
Yes, sir.
Okay, you can apply right hand thumb rule. Okay. So it will be helpful in rotational motion also. So make sure you can apply the right hand thumb rule. All right. So Florence, this is clear?
Yes.
Okay. So then now let's suppose our particle. Okay. So before that, so these are the average values of these quantities. And how do we find the instantaneous values? So for instantaneous angular velocity, what will we do? So it is omega bar equals to what? So we take the limit delta t goes to 0, right? It is limit delta t goes to 0 of delta theta by delta t. So it is d theta by dt. Okay. And similarly, the instantaneous angular acceleration alpha bar is given by limit delta t tends to 0 of delta omega bar by delta t, and this limit is known as the derivative of omega bar by with respect to time. Okay, so instantaneous quantities we'll find out just like we found them in case of the linear motion. Okay, so instantaneous angular velocity is d theta bar by dt. Instantaneous angular acceleration is d omega bar by dt. Okay, so after that, I'm sorry. So let's suppose the particle moves with constant speed. Okay, particle moves about the circumference of circle with the constant speed. So how do I find that speed? Okay, so time taken by it to complete one revolution is known as its time period. Okay, so this particle starts from this point, moves in anticlockwise sense, and comes back to the same point. Okay, comes back to the same point. Let's call it A in time capital T. So what would be the speed of this particle? So speed is equal to V, it is circumference of circle, the distance covered upon time taken. So 2 pi r divided by t, right?
Yes, sir.
Okay, and if it covers n revolutions in 1 second, okay, so frequency of revolutions is n is the frequency of revolutions. Okay, then it is equal to 1 upon t. Can I say it's 1 upon t? It covers n revolutions in 1 second. Okay, so frequency is 1 upon t.
Yes, sir.
Okay, how do we find that? See, time for each revolution. Calculate time for each revolution. So time for each revolution. How will you find? Time for each revolution is 1 divided by number of revolutions. Okay, 1 second divided by number of revolutions performed in second. Okay, so time for each revolution will be 1 second divided by number of revolutions performed in 1 second. Okay, so that time we call it as time period. Okay, t. So you know this n on left side, t on right hand side. So n is equal to 1 upon t. Okay, and you substitute that here. So what do you get? V is equal to 2 pi r multiplied by n. This is another formula for speed of particle in circular motion. Okay, this is another formula for the speed of particle in circular motion. Then now we have defined the angular displacement. Okay, angular displacement delta theta as angle covered, okay, by a particle performing circular motion. So now there is a relation between the arc length and the angle. We know that relation. Okay, so let's suppose our particle is performing circular motion on this circle. Okay, so this is my particle. It moves from this point to this point, right? So how much is its displacement? Its displacement is the straight line joining these 2 points. Okay, so now you can see this angle is small and you almost cannot distinguish between what? The distance covered on the arc and the displacement. Okay, so we can say they are almost same. If we take even smaller angle, they will be even closer. Okay, so this is delta s. Okay, the linear displacement and delta theta is the angular displacement. So what is relation between the linear displacement and angular displacement? If linear displacement is small, so delta s is small linear displacement and delta theta is small angular displacement. Okay, so then I can say that delta theta is equal to delta s divided by r. Okay, if angle is small, then you can say this arc length and this straight line, they are almost equal. Yes, no?
Yes, sir.
Yes,
Okay,
sir.
and then you can divide the left hand side and right hand side of this equation by delta t. So you get delta theta divided by delta t is equal to 1 upon r, or you can take that r on left hand side. So r multiplied by, okay, delta s upon delta t. So delta s upon delta t will give you the velocity, magnitude of velocity. We're just talking about the magnitude. Okay, and here on left hand side, this is angular velocity. Okay, this is angular velocity multiplied by r. Okay, so linear velocity is equal to, if you take the limit delta t tends to 0 on both sides. Okay, limit delta t tends to 0 on both sides, then you get linear velocity is equal to r times angular velocity, right? You get this. Okay, so this is true for small angles. Is it true for a large angle? So let's suppose I'm sorry, I take this much angle. Now will it be true? V equals to r multiplied by omega. Will it be true? Okay, so now let's suppose I want to find out average velocity. So is it equal to r multiplied by omega?
Yes, sir.
Actually, it will not be. See, I want to find out average velocity. What is this angle? It is distance covered. Okay, it is this distance covered divided by the radius, not straight line distance. Now, when angle gets bigger, the straight line distance and this distance, they will be different. Okay, so I can say that average speed is equal to r times omega, right? I can say average speed is equal to r multiplied by angular speed. Okay, but I cannot say average velocity is equal to. So how do I find average velocity? See, what will be average speed? Average speed, it is equal to, length of this arc, okay, divided by time, right? Length of the arc, so s upon time. So I can write that angle, okay, this angle suppose is theta. So from here to here, the angle is theta. So I can write this as r multiplied by theta divided by t. This is average speed, okay, and theta by t is what? Your theta by t is angular velocity. Okay, so this is average speed. V is equal to r times omega. And now suppose I want to find out average velocity. Average velocity. So how will I find it? It will be a straight line distance. This distance. Okay, this is point A, this is point B. So straight line distance from A to B, which will be less than, of course it will be less than length of this arc. Okay, so I will call it U. So U is equal to, it is equal to what? Length AB divided by time. Okay, so now can you tell me which magnitude would be more, average speed or average velocity?
Average speed.
Average speed will be more. Okay, so average speed you can always write it as r times omega, but average velocity you cannot say it is equal to r times omega. Okay, you can only say instantaneous velocity, the magnitude of instantaneous velocity is r times omega. So understood this? Okay, so v can be written as r times omega, right? So and omega therefore, so v is equal to 2 pi r divided by t. Okay, so v is equal to 2 pi r divided by t, and omega can be written as what? V upon r. So if you divide it by r, what do you get? You get omega equals to 2 pi upon t. Okay, you get this formula for angular speed. This is fine.
Yes, sir.
Yes, sir.
Okay, and you can say angle covered in one revolution is 2 pi, time taken for one revolution is capital T. So angular velocity is what? Angle covered divided by time taken, right? So you get 2 pi divided by t. Okay, and also it is equal to, if you keep 1 upon t equals to n, then it is equal to 2 pi times n. Okay, so you get this formulae for omega. So if object moves in a circle with constant speed, will there be some acceleration? If an object moves in a circle with constant speed, will there be any acceleration?
No, sir.
Okay, we are talking about uniform circular motion. So we have this object, okay, performing uniform circular motion. So initially it is at this point A, then in some time it moves to the point B. Okay, it moves till the point B. So now what will be the direction of velocity of this object when it is at B, A, and when it is at B? Let's suppose you take a stone, okay, you whirl it in this horizontal circle, okay, in anti-clockwise sense, and let's suppose the stone is at this point. If you release it, okay, if you release the string when stone is at this point, so in what direction it is moving when it is at that point? Sorry, it is moving along tangent.
Yes, sir.
Okay, so the direction of velocity at this point, it is tangent at this point. If you release the stone, if you release the string when the stone is at this point, it will move in this direction, tangential from that point. If you release it when it is at this point, it will move in this direction, okay, tangential to this point. And if you release it over here, in what direction will it move? It will move in tangential direction to this point. Okay, so what is the direction of linear velocity in circular motion? It is always tangential to the path. Okay, so instantaneous linear velocity is always tangential to the path of the object in circular motion. So our object is at point A. What is the direction of its velocity? It is tangential from this point. So this is the direction. Okay, when it is at B, what is the direction of velocity? Tangential at point B. Okay, so this is VA bar and this is VB bar. This is VB bar, right? So now I'm saying the object is moving with constant speed. Will there be any acceleration? Yes, there will be an acceleration because the speed is constant, but direction of velocity is not constant. Can you say this vector and this vector is equal?
No, sir.
No, right? Because they have same length, but they are not directed in same direction. Okay, so when object moves from A to B, its velocity changes. It doesn't change in magnitude, but it changes in direction, right? So now we have to find out how much is that change due to what? The direction of velocity only. So we are talking about uniform circular motion in which magnitude of the speed remains constant, magnitude of the velocity, which is speed, remains constant, okay, but direction changes at each and every point. It is always tangential to the circle, okay, and therefore there is an acceleration due to change in direction of velocity only, and that acceleration is known as the centripetal acceleration. Okay, that acceleration is known as what? The centripetal acceleration. Oh, I want to erase this B only. Okay, so now my object is moving from A to B. Okay, so object is moving from A to B. Okay, velocity at this point is VA bar. It is tangential at this point. Velocity at this point is along the tangent at this point. So what will be change in velocity? It will be VB bar minus VA bar. So to subtract it, I will move this VA bar over here. Okay, so I will draw VA bar at this point. Okay, so it is this much, right? So this is my VA bar. Okay, so this is, I can say RA bar, the radius vector when the object is at point A. This is RB bar, the radius vector when object is at point B. Okay, this is the origin. So what will be the change in velocity? So we know that if I draw a vector like this, let's use different color. If I draw a vector like this, okay, from tip of VA bar to VB bar. So this vector will be delta V bar, the change in velocity vector. How? Because VA bar plus delta V bar gives me what? VB bar. Okay, so therefore delta V bar is equal to what? VB bar minus VA bar. Okay, and let's suppose the magnitude of VA and magnitude of VB is equal, and suppose it's equal to V. Okay, so now if I draw this straight line, okay, this straight line like this, so what will be this vector? This is delta R bar. Okay, can you see this? This is delta R bar. What is delta R bar? So in triangle OAB, or I will call this one radius triangle and this one the velocity triangle. Okay, so if you see the velocity triangle and the radius triangle, so this angle is suppose delta theta, this angle is also delta theta. So can you see that these two triangles are similar? These are two lines, two radius vectors. The angle between them is delta theta. Okay, I draw a perpendicular to first vector. This is perpendicular to first vector and this is perpendicular to second vector. So if angle between two lines is delta theta, the angle between perpendicular drawn to those two lines will be equal. Buying my
Yes, sir.
argument?
Yes, sir. Yes, sir.
Okay, so if angle between two lines is delta theta, angle between perpendiculars drawn to those two lines will be same. Okay, because both lines are rotated by 90 degrees, so angle between them will not change, right? So this angle is also delta theta. Okay, so you can say in this velocity triangle, this side and this side is equal, angle between them is delta theta. In the radius triangle, okay, this side is equal to this side, both are radii. Okay, and angle between them is also delta theta. So by SAS test, these two triangles are similar. Okay, if we compare the velocity triangle and radius triangle, so comparing the velocity triangle and radius triangle, we can say that they are similar. Okay, they are similar by they are similar by SAS test, or I can just say the velocity and radius triangle are similar by side angle side test. So do you know this fact that the ratio of two sides, okay, to corresponding sides of similar triangles are equal? So if I take
Yes,
delta
sir.
V divided by VA, which is equal to what? V, length of this side divided by length of this side, it will be equal to length of this side divided by length of this side, which is R. The magnitude of RA bar is equal to magnitude of RB bar, and it is equal to R. Okay, so I can say, therefore, taking ratio of the corresponding sides, so delta V divided by V is equal to delta R divided by R. Can I write this?
Yes, sir.
Yes, sir.
Okay, and now you can take this V on right hand side and you can write delta V is equal to delta R, okay, multiplied by V divided by R. Okay, and then what I will do is I will divide by the time. Okay, I will divide by the time. So dividing by delta t and taking the limit delta t tends to 0. Why am I doing this? I want to find out acceleration. So I can say that limit delta t tends to 0 of delta v divided by delta t, it is equal to limit delta t tends to 0, v upon r, you can take it outside, delta r upon delta t multiplied by v upon r. Okay, so tell me, what is this? This is instantaneous
Acceleration.
acceleration. And what is this? This is instantaneous
Instantaneous velocity.
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 Okay, so it is equal to v. So this instantaneous acceleration is because of what? Change in which thing of velocity? What did we consider? Did we change the length of velocity? Did we change the magnitude of velocity? No. We have considered that magnitude of velocity at this point, okay, and this point, at this point, they are equal. Magnitude remains same. That means speed remains same. What is changing? Only direction is changing. Okay. So this acceleration is purely due to change in direction of velocity. Magnitude is constant. Okay. So we are talking about uniform circular motion, right? So this acceleration is because of what? Change in direction of velocity only, right? And how much is that? So I can write this as, this is acceleration. Okay, it's equal to this v multiplied by v upon r. So I can write this as v square divided by r. Okay, so this acceleration is due to change in magnitude of velocity only, sorry, change in direction of velocity only. Okay, purely due to change in direction of velocity. Okay, we didn't consider change in the magnitude at all, right? So now the direction of this acceleration will be along the radius and towards the center. Okay, see, at this point it is directed like this, but we have taken a large angle. Okay, so if we take sufficiently small angle, you will see that its direction will come out to be like this. Okay, at it is at this point that we are calculating, will be directed along the radius and towards the center. Now it is a little bit off. Okay, it's not parallel to this, right? If you take sufficiently small angle, it will be
Yes, sir.
directed along the radius and towards the center of the circle. And we'll prove that tomorrow. So when we'll find out the same thing using the calculus method. Okay. So it is directed along the radius and towards the center. It is directed along the radius and towards the center, and that's why it is known as centripetal acceleration. Centripetal means what? Towards the center. Center seeking acceleration. Okay, so therefore this is known as, it is called as centripetal acceleration. It is called as centripetal acceleration. Acceleration. Okay, it is also called as radial acceleration. Why? Because it is along the radius. Okay, so how can I write this in vector form? So in vector form, okay, so now we'll put suffix c over here. Okay, if you like, you can put suffix r. So why the suffix c? Because it's directed along radius and towards the center. Okay, so this AC bar is equal to v square upon r multiplied by r cap. Is it correct? To show the direction, I will use unit vector in direction of radius vector. So is it correct?
Yes, sir.
Yes, sir.
There should be a negative sign because the radius vector is directed along radius. True, but it is directed away from center. See, the radius vector is directed away from center. It's going away from center. And the centripetal acceleration is directed along radius and towards center. Okay. So what should be there? There should be a negative sign. Now it is correct. Okay. So points to
Yes,
be
sir.
noted about the centripetal acceleration. It is along radius and towards center of the circle. Okay. So it is opposite to that of radius vector. Second thing, it is purely because of what? The change in direction of velocity, not due to change in magnitude of velocity. Okay. So now, if you change the magnitude of velocity also, will there be some acceleration? Yes, there will be some extra acceleration, right? This is uniform circular motion. So if we talk about non-uniform circular motion, non-uniform circular motion. Now, so let's think about this case. So let's think about a case where the particle, oh, your particle is at this point, okay, and you're accelerating. So let's suppose you are driving your bike or your scooty, anything, okay, and you're driving it along a circular track. So at a particular point, you accelerate very fast, okay. So your radius won't change much. We can say the radius is constant for very short moment. You can say it, radius is constant. What's changing? The speed is changing. Speed is changing instantaneously. Okay. So can I say this? Yes, no.
Yes, sir.
The speed
Yes, sir.
is changing instantaneously. So what will be direction of that change in speed? In what direction is that speed changing? It's along the tangent, right? So initial speed, initial velocity is also along the tangent, and you accelerated. You didn't move much. So your final velocity is also along the tangent, right? At a particular
Yes,
moment,
sir.
you are accelerating. So initial velocity is also tangential to this point, okay, and within fraction of second, you are accelerating your scooty or your bike. So final velocity is also in the same direction. So what will be change in velocity? What will be direction of change in velocity? Final velocity, which is, let's suppose, this much, minus the initial velocity. Okay, the final velocity, which is this much, minus the initial velocity, which is this much. Okay, so this is v2 bar, this is v1 bar. So in this case, the acceleration that you get when you change what? The magnitude of magnitude of velocity only, magnitude of tangential velocity. So this acceleration is known as the tangential acceleration. Okay, so the tangential acceleration AT is due to what? Is due to change in magnitude of velocity, right? Got this? Yes, no?
Yes, sir.
Okay, Sanjay, Florence, is there a question?
No, sir.
Okay, so you got that this is because of change in magnitude of velocity. Centripetal is due to change in direction of velocity. Okay, so we can calculate this. So tangential acceleration AT is equal to what? It is equal to final velocity v2 bar minus v1 bar divided by very short time, fraction of second, delta t. Okay, and then now, oh, what did I do? I'm writing acceleration as a scalar and velocity as a vector. Okay, so now see, now what can I say? This is v2 bar minus v1 bar. So v1 can be written as r times omega 1. Okay, the speed can be always written as what? R multiplied by angular velocity, and v2 can be written as r multiplied by omega 2. So using this, I get the tangential acceleration is equal to r times omega 2 minus r times omega 1. So if I take r common, it is omega 2 minus omega 1 divided by delta t. And what is this? This is angular acceleration. Okay, so this is equal to, see, change in angular velocity with respect to time is angular acceleration. So AT is equal to what? Tangential acceleration is equal to r times alpha. Okay, the angular acceleration. Okay, we have tangential acceleration, we have centripetal acceleration. So what will be the total acceleration in non-uniform circular motion? So it will be vector sum of the tangential acceleration and the centripetal acceleration. Okay, so total acceleration in non-uniform circular motion okay, it is a bar is equal to what? AC bar plus AT bar, right? And so if our particle is here, what is direction of AC bar? Along the radius and towards the center. What is direction of AT bar? It's like this, it's along the tangent. Okay, so this is your AC bar sorry, this is your AC bar, the centripetal acceleration, this is your AT bar. Okay, what will be direction of resultant? So if you think about the parallelogram law of vectors addition, the total acceleration will be directed along the diagonal of this rectangle. Okay, right? So this is your total acceleration. This is the total acceleration. Okay, so which is a bar. So this is a bar. Now we know about the resolution of vectors. So I can say that magnitude of this A is equal to square root of AC square plus AT square. Okay, and if the angle between these two is theta, then what can we say about this theta? What will be tan of theta? If the angle between centripetal acceleration and total acceleration is theta, what will be tan of theta?
AT by AC.
It will be AT by AC. So tan of theta equal to, it is equal to AT divided by AC. Okay, simple, right?
Yes, sir.
Yes, sir.
Yes.
Okay, so is there any question till now?
No, sir.
No, sir.
Everything
No,
is clear? Okay. So tell me, tangential velocity is because of change in which thing of, sorry, tangential acceleration is because of change in which thing? Magnitude or direction?
Magnitude.
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 And centripetal acceleration is because of change
magnitude.
in
Direction.
direction
Direction.
of velocity. Okay. So keep that in mind.
Direction.
There can be direct questions based upon this. Okay. So now let's solve 2-3 questions. Okay. And rest of the questions and remaining theory also we'll see on tomorrow. Okay. So two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speed VA and VB respectively. The time period of rotation is same. Time period of, they mean to say the revolution. Okay, they are moving in circular motion. Time period of revolution of both these particles is same. Then the ratio of angular speed of A to that of B will be. So how do we solve it?
T is equal to 2 pi by omega.
T is equal to 2 pi by omega. Okay. So omega is equal to 2 pi upon T, or T is equal to 2 pi by omega. So if T is equal, can I say omega will be equal?
Yes, sir.
It's inversely proportional, but still there is no other variable. So if T is equal, if time period of rotation or revolution is same, omega will be same.
Yes, sir.
Yes, sir.
Okay. So what is the ratio? 1:1. Okay.
1:1.
1:1 is the answer. Okay. So next question. An electron is moving in a circle of radius 2 meters with speed of 4 meters per second. Find the acceleration of the electron. Tell me. What will be acceleration?
V square by R.
V square by r. Okay, it is centripetal acceleration only, right? It is moving with constant speed in a circle, so there is no tangential acceleration because speed is constant, magnitude of velocity is constant. Okay, so centripetal acceleration only, which is v square by r, which is 4 square divided by 2, because speed is 4, radius is 2. Okay, so 16 divided by 2, answer is 8 meters per
8.
second square. Okay. Oh, I forgot to tell you one thing. So there are other formulae also for centripetal acceleration. So this can be also written as r omega square. Okay, r bar minus of r bar omega square. How? So in place of v, I can substitute what? R times omega. Okay, so this will be r
Yes, sir.
square
Yes, sir.
omega square. Okay, it will be r square omega square divided by r, and this r gets cancelled out with this r, so you get r omega square multiplied by, you have r cap and this negative sign. So this r is the magnitude of radius vector, this is the direction of radius vector. Magnitude multiplied by direction will give you the radius vector. Okay,
Yes, sir.
Yes, sir.
so
Yes,
this
sir.
is another formula for centripetal acceleration. Okay, and there is yet another formula, but I will just write it right now. It is omega bar cross v bar. This one we cannot see right now. Okay, so this will understand when we know about the cross product of two vectors. Okay,
Yes,
Yes,
sir.
sir.
so see, we can talk about the magnitude. So omega is equal to what? V upon r. So magnitude of this one will be what? V upon r multiplied by this v square upon r. Okay, but how does this direction comes? Okay, why it is omega bar cross v bar and not v bar cross omega bar, that we cannot understand right now. Okay, so we'll discuss about that later, but we can note down this formula. Okay, so this is clear, right?
Yes, sir.
Yes, sir.
Okay, so yeah, so we'll talk about this topic once again in rotational motion. So then we'll discuss about how does this formula comes about. Okay, okay, tell me this question. In the given figure, a is equal to, what is a? This is a. The acceleration is 15 meters per second squared, represents the total acceleration of a particle moving in clockwise direction. It's moving in clockwise direction in a circle of radius r equals to 2.5 meters at a given instant of time. The speed of the particle is. What should we do? Acceleration is given. What is this acceleration? Is it centripetal? Is it tangential? Or is it the total? It's total, right? It's not directed
Yes, sir.
along the radius, so not centripetal, not directed along the tangent, so not tangential. It is total acceleration. Okay, and we just studied how do we find centripetal acceleration if angle between the centripetal acceleration, this is AC, and the total acceleration is theta. So
A cos theta.
it is a cos theta. This is, we are just resolving a bar in two perpendicular components. So AT is equal to a sine theta in magnitude. Okay, magnitude of AT is a sine theta, and magnitude of AC, which we know need now, it is a cos theta. And what is theta? 30 degrees.
30 degree.
A multiplied by cos of 30 degrees. What is cos 30?
Root 3 by 2.
Root 3 by 2. So let's substitute the values. Okay, we are asked with the speed of particle. Okay, we are asked to find the speed of particle. So centripetal acceleration can be written as what? V square by r. It is equal to a times root 3 by 2. So take this r on other side and you will get v square equals to a multiplied by r root 3 by 2. That is, a is 15, r is how much? 2.5. Okay, 2.5 multiplied by 1.732 divided by 2. Getting the calculation. So this will be 1 point, if we divide this with this will be 7.5. 7.5 times, okay, this is the v square and we want square root of that. So it is 7.5 multiplied by 2.5 multiplied by 1.732. Approximately, can somebody say? Sorry. 7.5 times 2.5 times. Okay, so can I say it is 8 times 4, near about 32 or something? Oh, the options are also close. This is not expected in NEET exam. It is the NEET question. What will be V? This we have to calculate, right? There is no other option. Okay, do you have cell phone? I have cell phone. Okay, square root of 7.5 multiplied by square root of 2.5 multiplied by square root of 1.732. 5.69. So option C is the answer. Okay. So 5.7. Yeah, I said about 32. Yes, of course, this will be greater than, okay, we can do it this way. It will be greater than 25, but less than 36. Right, we can get it that
Yes.
way. Okay, so it is 5.69 is the answer for 5.7. See this next question. The length of seconds hand of a clock is 10 centimeter. The speed of its tip is nearly. Simple, right? Speed is equal to what? V is equal to R times omega. Okay, what is omega? Angular speed of seconds hand. So omega is equal to 2 pi divided by t. Okay, what is the time period of seconds hand in a clock? How many seconds?
60.
Is it 60 seconds? Yes, it is 60 seconds. Seconds hand completes one revolution in 60 seconds. Okay, so this is 10 centimeters. 10 centimeters multiplied by 2 pi divided by 60. Okay, so again we have to do some calculations. So 10 centimeters multiplied by 2 multiplied by 3.14 divided by 60. So near about, can we say this thing and this thing gets cancelled out? 10 divided by 10. So 1 would be the answer. Yes, no? Near about it's 1. Okay, so this is simple question, right?
Yes, sir.
Apart from
Yes,
the
sir.
calculation part. Calculation, okay. And calculation also, this is 2 multiplied by 3.14. Okay, this is close to 6. And options are distinct. Okay, they are well separated. So this will be the answer. 10 divided by 10. This is 6. Okay, 10 6 are 60. So in denominator we have 60, numerator we have 60. So 1 centimeters per second is the answer. Okay, so a particle is moving uniformly in a circular path of radius r. When it moves through an angular displacement theta, then the magnitude of corresponding linear displacement will be. And all the options are in terms of theta by 2. Okay, so let's see this one. So our object moves with an angle of theta. So initially the object is here and it moves through angle theta. Okay, so because all the options are in terms of theta by 2, there will be some relation. Okay, so what will we do? We'll draw angle bisector, right? And we'll join this line. So this is the displacement. How much is displacement? AB is the displacement. This is radius. How much would be this angle or this angle? Theta by 2, right? This is theta by 2. This is theta by 2. So can you say how much would be the displacement in terms of theta by 2? All the options are in terms of theta by 2.
Yes, sir.
Yeah, tell me. It is this length plus this length, right? Okay, so we have named it already. Let's call this point C. Let's call this point C. Okay, this is the point C. Okay, so can I say it is AC plus CB? Displacement is equal to AC plus CB, right? And if you see this triangle, so in this triangle, What is CB? You can write it in terms of this angle. It is opposite side divided by hypotenuse. Okay. So sine of theta by 2 is equal to, okay, if you look in this triangle, it is CB divided by R, and in this triangle it is AC upon R. Okay, it is equal to AC upon R, and therefore AC is equal to R multiplied by sine theta by 2. And also in this triangle, I can say BC or CB is equal to R multiplied by sine of theta by 2. And the total distance from A to B is this distance plus this distance, right? So it is displacement AB is AC plus CB, which is R sine theta by 2 plus R sine theta by 2. So it is 2R times sine of theta by 2, right? So a ball is moving in circular path of radius 5 meters. Tangential acceleration at any instant is 10 meters per second, and net acceleration makes an angle 30 degree with the centripetal acceleration. Then the instantaneous speed is. This is similar to one question that we had seen. Okay, so tangential acceleration is given. What is given? Radius r is equal to 5 meters, at is equal to 10 meters per second squared, and the angle between net acceleration and centripetal acceleration is given. So okay, so centripetal acceleration and the net acceleration, this angle is given, this is 30 degrees, right? So this is AC, this is total acceleration A. Okay, so from this we can find out AC.
Tan theta equal to tangential acceleration by centripetal acceleration.
Tan theta equals to, right, so tan theta equals to, yeah, tangential acceleration is given because, okay, so we will find out tangential acceleration divided by centripetal acceleration. It will be equal to tan of theta. Good, Sanjay. So tan theta, tan of 30 degrees is at divided by centripetal acceleration, and therefore AC equals to at divided by tan of theta, tan of 30. Okay, and we are asked for the instantaneous speed. So v square upon r is equal to this, at divided by tan of 30. How much is tan of 30? 1 by
1 upon root 3.
1 upon root 3. So 1 upon root 3. Root 3 goes to numerator. Okay, so take r on the other side. R is 5. So v square is equal to 5 times 80 is 10 times root 3. And once again we have to find out v. So this will be v will be equal to what? Square root of 50 root 3. Okay, so directly it is given. No, it's not. Okay, square root of 50 multiplied by 1.73. Okay, I thought this is the answer. Okay, so it will be 7 multiplied by something, 1 point something, 9.3 would be the answer, right?
Yes, sir.
Because others are less than 7. This cannot be the answer. This is v square, this is not v, right? Yes, no?
Yes, sir.
This is 50 approximated to 49. Square root of that is how much? 7. 7 multiplied by square root of this. Okay, this is 1.732. Approximately Okay, 1.732. Whatever it is, its square root will be greater than 1 because square root of 1 is 1. Okay, square root of this thing will be greater than 1. So you have 7 multiplied by square root of this, which is greater than 1. So answer is definitely greater than what? 7. Okay, so this cannot be the answer, this cannot be the answer. So it will be 9.3. This is anyway not the answer. This is v square. It's not v. Okay, so answer is this one. Okay, this is clear.